We will talk about, obviously it's another class on extremum values. And today we have extreme values and optimization. All right, so first thing is that this topic is the nature of a stationary point determined by the eigenvalues of a Hessian matrix. Okay. So we had a proof in the last class, and the proof was establishing the Taylor's formula, I think. So we established the Taylor's formula. Now we will use that to make the connection between the stationary points and the Hessian matrix. We met the Hessian matrix in the last class as well. So, okay. Now, so we know that so for stationary points, from now on I will use a shorthand S dot P. The stationary point A, this is true. Okay. So the second order Taylor formula becomes it becomes so for the Hessian matrix I will use this notation. So this, this is a matrix. Okay, so Hessian matrix will be denoted by this symbol, third bracket. All right, and so Y's are row vectors. That's the second order Taylor formula. So from here, we can see that the algebraic sign is actually related to the right side, which has the quadratic form, and I made a mistake. Why is the t came in here? Sorry. It must be square. So the Taylor formula, okay, tells you that the algebraic sign of this term, either is positive or negative, depends on the right side. And the right side has this piece where this is strictly positive, as it's a norm and a square of a norm, and it's a non-zero vector, but it can approach zero. And there is something of an error, okay? And the error can be anything, okay? So we have to show that so what was our goal? Look at that. The nature of stationary point determined by the eigenvalue of the Hessian. So it only depends on this thing. We have to show that the algebraic sign only depends on this thing, not depending on this thing. So we have to establish that. Okay? So that's the goal. So as that's the goal, so let us have a proof. Okay? Let us prove the the claim in the heading. Okay, the claim in the heading was this topic 1. This is the claim. and we want to prove it. So the proof will be based on two things. One, I have to, so you have a Hessian matrix and you have a quadratic form. So first thing is to show that, is to show the connection between the, okay, so first thing, if you have a matrix, then you want to diagonalize it so that you can talk about its eigenvalues. Then it is easy to make a comparison with the algebraic sign on the left and the sign on the right. Okay? So in the first proof, we do that exactly. Try to establish the connection with the eigenvalues. So theorem 1. Yeah.
If the condition is like that, where error terms and E2 goes to 0 as y vector goes to 0, right?
Right.
But then since the y vector is also in the first term, right? That will also go to 0?
Yeah, that will go to 0 as well.
So both terms will go to 0?
Yeah, both terms goes to 0, yeah. But E2 goes to 0, it itself doesn't have to many. Okay. E2 goes to 0 as y goes to 0. It is, yeah.
Regardless of the first term.
Yeah, regardless of the first term. Yeah, error term is defined that way. Okay. So, theorem 1, let A so the point is that so y goes to 0, this error term drops off, everything drops off. So that's not that doesn't give us anything, no?
I think
Right side, left side equally, identically 0. So that's.
At the chain rule there was an issue. If we only take y tends to 0 and not the other thing, then I think at the chain rule there was a 0 by 0 division.
On the other thing.
Chain rule.
What the other thing?
V modulus of V by modulus of.
Well, that's a different thing.
Yeah,
That's a different
we
thing.
can only take that, but we cannot.
But they're systematic. One depends on another, and
we cannot prove. If we don't take the first argument, we cannot prove the chain rule because all the.
Well, here chain rule is not important.
Yeah, but I'm just saying that if we don't take it, then we cannot.
Yeah, that's a different discussion. I have to look through that. But that doesn't have anything to do here.
Yeah.
So, okay, so let A, which is an n by n square matrix, just look at it, but it's more than that. That has to be a n times n real symmetric matrix. Okay, and let Q of y. So okay, so it's a scalar. Sorry, Q of y is defined by this, a quadratic form, and you can write it in terms of equations. Or I can say capital I. Okay, then we have Q of y greater than 0 for all y not equal to 0 if and only if all the eigenvalues of A are positive, and B is Q of y less than 0 for all y equal to 0 if and only if all the eigenvalues of matrix A are negative. So it connects the quadratic form with the eigenvalues of the Hessian, well, in this case, symmetric matrix. Forget about Hessian, some symmetric matrix. Hessian is a symmetric matrix, so can't forget about that. So let's go to the proof, delve into the proof. So a real symmetric matrix is diagonalizable. Now that I am not proving, but it is left to your linear algebra course. Matrix is diagonalizable. Okay, that is the matrix A, and it has a diagonal matrix counterpart D, and they're connected by some C, where C is an orthogonal matrix. Matrix, namely, it means that C transpose C is equal to CC transpose is equal to 1. So there exists, yeah,
Symmetric matrix is diagonal
diagonalizable. Diagonalizable.
What can be diagonalized?
The diagonalizable means that all the entries are either diagonal, everything else is 0. And essentially they are eigenvalues. So, yeah, well, yeah. So all the eigenvectors are linearly independent. So you are writing the matrix in its eigenbasis.
Can you please tell what is orthogonal?
The definition is given. The name orthogonal means that it satisfies the property. That's property. The intuitive idea is that if you have radius, so if you have a vector in space and you have its length r, then r square is its norm square.
Yeah.
So you can write it as a vector notation like this. Then if you rotate this vector from this to this, some other vector, say r prime, so you have a r prime square, which is a r prime dot r prime. Then this r and r prime are related by, however, because this is a matrix notation, one of them will be transpose. One will be row and column. Okay. So this r prime is related to r by some c. So you have this c r transpose dot cr, and then you have r c transpose c r. So if you demand, that the norm doesn't change by this transformation, I'm just rotating the vector. The endpoints are, one endpoints are fixed, another endpoint are changed, rotated. But I haven't really squished the vector. I haven't really done anything with its length. So it should be the same. That's what prompted this definition.
Aren't they unitary matrices?
So you want to write the last
I'm sorry. So yeah, this, if you demand that C is such that this is true, then this must be 1.
Aren't they unitary matrix?
I'm sorry?
Unitary matrix.
What is unitary matrix?
Unit.
No, which one?
C, T, and C.
No, they are orthogonal.
Okay.
Yeah. Orthogonal unit matrix is a special orthogonal matrix. It's the matrix which represents no change.
Yeah, but what is this question? You see, unitary matrix is a different thing.
I thought that unitary matrix was something that which has a modulus of 1, which is a
Modulus of-
derivative of 1. Sorry.
So what's the question? Can I hear?
U dagger is equal to identity. When he's asking about the unitary matrices.
That's a generalization of orthogonal matrices. Unitary matrices act on complex vectors.
That's not. Hermitians are the generalization. Yeah? Or is that so?
Well, they're both.
I'm sorry.
Hermitian, no. So Hermitian
Well,
matrices are generalization of symmetric.
He's
matrices.
right. Hermitian matrices are symmetric matrices. This is the unitary matrices generalization. Yes, you are right. So they are unitary matrices. Yeah, but I didn't want to use that word because that's more for complex.
The other thing is that
You're right. They are unitary matrices if you restrict your domain to reals. But yeah.
the orthogonality condition that Abhijeet is writing down, C transpose C is equal to C transpose equals to 1, means that C transpose is equals to C inverse.
Exactly.
The other thing is that it's not only rotation which can be orthogonal, it can be reflection,
Yes.
which is also orthogonal.
By this definition, yes. Yeah. Well, whatever doesn't change the norm. So you can reflect it doesn't change the norm.
I don't know if they may not be familiar with the fact that when you reflect a vector, you cannot rotate to that vector.
You can. When you have a mirror reflect, you can. There is.
Not in 3 dimensions.
Yeah. Yes, not in 3 dimensions. Yeah, not in
Or
3
any dimensions.
No, there is in 2 dimensions. There is. Even dimensions, there is a rotation which corresponds to the reflection with a pi.
Never.
No, there is. There is one pi. Actually, we'll talk.
We will talk about this later.
Talk about this later.
Right.
Yeah.
Yes.
We'll talk about this. But in odd, there is no possibility. Okay. Yeah. But because you have -1, if you reflect both of them, x and y in 2D.
If you rotate 180, it becomes reflection.
In 2D, if you reflect both of them, x and y.
180 degree.
Reflection is by definition putting a mirror.
Yeah, right.
And in 2D, when you reflect through a mirror, you're only changing one of the components.
That would be a definition, yeah. So that kind of eliminates it. If you reflect,
Because, if you reflect, if you invert both, then it's a determinant one matrix.
Exactly.
So it is not a reflection.
it's not a reflection anymore, yeah.
It is a rotation by 180 degrees.
Yeah. So that probably would sit in the definition of a parity. Reflection is what Sar is talking about. You cannot do that if you have to have that determinant -1. But talking about parity, you're talking about parity, you can change both of them. Then it becomes rotation. That's what essentially my point was. Yeah. So, yeah, okay. So, okay, it's a little bit detour into that direction, but okay. Okay, so orthogonal matrix. Okay, so it is diagonalizable and all that. So we could do that. Let's do it. Let's use it in the Q. So we have a Q definition, which is, I think, this. Okay. Then I will substitute what we have found earlier. Now I should be actually using, these are all matrices. So there's this thing, matrix notation. Okay, this is this, and that goes there. There's, oops, that's all right. And then you can say, okay, this is a new vector. Okay. New vector. Okay, and then x is y, c. Now, this is a quadratic form, and this is a diagonal matrix. Yeah.
So
What does it mean?
It's possible to take the commonality of the transpose, say C matrix plus C transpose multiplied Y transpose. So we can have this C and Y.
I think I made a mistake, nah? I made a mistake. Yeah, I made a mistake. Yeah, I think this should be this. I'm sorry. Yeah, sorry. Transpose switches them. Yeah, sorry. Thank you. All right, so you have this lambda I x I square by definition. However, everything else would be 0. So only the diagonal terms we picked out. The definition of a diagonal matrix is that all the entries in the diagonal. Okay. where lambda i's are real. Why? Because the matrix is symmetric. Okay. That's also a theorem. Okay. So we are here. Now, look at our goal. Our goal was to prove that this is 0 or greater than 0 for all of the vectors which are not equal to the 0 vector. Okay? If and only if all the eigenvalues are positive. So we are about reaching there, but we have to make sure that this condition is satisfied. Okay? So let's try to achieve that. So let me call this is equation 1, this is the same equation 1. So equation 1 implies that q of y is greater than 0. Obviously xi square is positive, so it's greater than 0 if all lambda I are positive. Now, okay. Sounds a bit weird. Am I going for that? Yeah, the eigenvalues. Well, if you demand that Qi is strictly positive, not in this case, it's more general. It's a symmetric matrix, real symmetric matrix. So
aren't we supposed to say the determinant?
No, not yet. We haven't said any word about determinant yet. We will, however. I was thinking, so what does this line mean? This means lambda 1 x1 square, lambda 2 x2 square, la la land. And the question here is that can ask, can this be positive having some terms negative? No, yeah. For positive lambdas, it has to be positive. But we have not shown that the lambdas are positive, have we? We're saying the lambdas are there, which is true. They're real. We're not saying they're positive.
No, you are stating that
We are stating that, exactly.
Yes,
So you can have some of the lambdas negative and still Qi would be positive. There is a chance that Qi could be positive. But you can guarantee, undoubtedly, you can guarantee that Qi is positive if all the lambdas are positive. You can guarantee that. Okay? Thank you. That was the point. We're stating that. Right. If all lambda are positive. Okay. I think I should change the way I wrote it. The way I wrote it, I want to change it. Because that means that Qi is only positive if all the lambda is positive. That's not true. No? You can have few lambdas. Okay? So yeah. So from equation 1, yeah. When all exactly. When all the lambda I positive, then Q of y is going to say. This is much better still. No, that's the whole point. No, because not if and only if. That's the whole point I was worrying about. Because Q of y can be still positive if you have a few negative eigenvalues. No, one eigenvalue is bigger. This happens in statistical mechanics. You have the Ising model, no? You have this, whatever is the bigger which dominates it. Well, something. You have two eigenvalues. If something is positive and is bigger than the negative in magnitude, then it dominates. Then still Qi is positive, even though not all of the eigenvalues are positive. So not if and only, but if I can ensure that all the eigenvalues are positive, this is true. So yeah. নোট তোলার সময় মাঝে মধ্যে থাম করে ছোটো ছোটো স্নিপেট তুলে ফেলি স্নিপেটস আর times and the strong scrutiny goes into trouble. So we met this thing, okay? Now there is a little bit of washing up to do. So we have this, yeah, question? So we have this, and this implies C is orthogonal, and as Sar was pointing out that C has a matrix, C has an inverse. Orthogonality definition really requires you to have an inverse. And a more deeper reason is that it is a group, so it must have an inverse.
Yeah,
It forms a group.
It's also a normal matrix, right?
Yeah, it's a normal matrix.
That C
Daggers,
the
I think.
inverse is equal to C inverse C.
Right.
The left inverse is equal to
The right inverse, yeah. Yeah.
That's normal, is it?
I think the normal was n and dagger is equal to some.
I think that's it.
Yeah.
C into C inverse is equal to C inverse into C. It is.
No, that's normal.
Is it?
Yeah.
Remember? Okay, I have to check the definition for
Yeah, the left inverse and the right inverse are the same.
Yeah, but that would connect with the normal, no?
I think that is.
Okay, I have to look at it. I was connected with something else as well. But, I remember. Yeah.
Or it's a transpose.
Instead of it's a transpose.
Yeah, it's a transpose. Transpose A is A transpose.
Yeah.
That's normal. That's a normal matrix.
Yeah. So there are certain theorems you can prove for normal matrices. Turns out this is one of them. All right, very good. And then what you can do, we have arguments for y, not for x. So let's go back to y. And because this is invertible, this must be C inverse. The way I would write inverse is this way. The matrix representation of the inverse. And we have it. So this is true whenever, I have to use one word, whenever x is not equal to 0. This is important here. This statement here is important. Okay? Because otherwise it would be 0, no? Yeah. So this would imply, this from this to this would imply that the y cannot be equal to 0 as well. Now here if and only if comes in. If and only if the statement was for y, not for the eigenvalues, for the y, if and only if statement was. So if you start with this, okay, so conversely, q of y greater than 0 for all y not equal to 0, okay, you start with it.
In the statement, it says that
Yeah.
for all y not equal to 0,
Yeah.
comma, then if and only if all the eigenvalues of A.
Yeah, that actually clings with the y. That
If and only if applies for
y. Yeah. So q of y for all y not equal to 0. We are going to do this right now, and you will see.
Then the phrasing is.
Yeah, we will see the phasing. Yeah, just let me go the proof and then come to the statement. Okay. Yeah. So here what we have done here, the y was important here. What we have done is we have shown qy is greater than 0, which implies y is greater than 0. Y not equal to 0. Sorry, y not equal to 0. Okay. But not 0 vector, because it's a vector. It's not equal. It's greater than 0 doesn't make any sense. It's not a null vector. Okay. So now what we are going to do, we are going to do the opposite. Okay. So q of y is greater than 0 for y not equal to 0. So choose, and then what we have been able to show also, that you have all the eigenvalues are positive. Okay, in that case. Okay. So So Q of y greater than 0 means all the eigenvalues are positive such that y is also not a null vector. Okay. Now we are starting with saying that, okay, let's start Q is greater than 0 for all y not equal to 0.
So this is another.
Then the eigenvalue conclusion would come in. Then the eigenvalues are all positive. That's what you're going to show. Does it ring the bell with the theorem?
Yeah.
So choose, the same argument will be just repeated in the opposite fashion. Now we are going to rotate it back to a coordinate axis. We can do that. We have a vector and you can, when C's can also change to one of the coordinate vectors. The question is the coordinate vector has a norm 1, so C does not affect the norm of the y or x. Okay, so you might like to normalize your system before you do this, which is skipped. Okay, you can always do that. So normalize these things. So let us do it in that fashion. Before doing that, let us normalize our vectors. So I will call them x hat, y hat. So if that is true, then choose C such that an orthogonal matrix is such that you would have an x hat, y hat, C, such that this x hat is nothing but ek, where EKs have norm 1 for any k.
So you are mapping it to a coordinate basis.
Yeah, mapping it to an ordinary basis. So I will rotate it to all the bases and I will pick out all the eigenvalues from those bases. That's exactly what I'm doing. Yeah. Therefore, we will have the quadratic form which we had earlier. So I had in 1. So a particular one. So I will use this form. I'm going to use this form. So that will give us something. Okay. It will only give us. Okay, let me write it thoroughly. Now, because we demanded that Q of y is greater than 0, the eigenvalue will also be greater than 0.
Previous argument still comes here again. Oh, sorry, it is the one also.
Yeah?
Like is it the one also?
Kunta.
The one.
Which are going to do ones? I'm sorry.
X I squares. Like is it the one also?
Yeah, so only lambda k is left.
Yeah.
Yeah.
So does EK mean the elementary?
Yeah. Coordinate. Yeah, there are coordinate functions. When one at the k position, everywhere else is 0. Yeah.
But again, the previous argument, we can use the previous argument, but there can be some lambdas which are negative and some lambdas.
No. That argument cannot be used here, strictly speaking, because Q of y is 0 to begin with. Q of y turned out to be lambda k. It cannot be negative.
Oh,
It has to be greater
It
than
has to be greater than 0. Okay.
So,
so there was no summation over K.
Abhijeet, can I ask you?
There is a summation over K.
Why does it have to be positive?
Which one, sir?
Why does Q of I have to be positive?
It's a definite, we assuming that Q of y is greater than 0 for all the y vectors not equal to the null vector.
You're assuming.
You're assuming that.
Uh,
That implies the eigenvalues must be,
for the proof.
yeah, all the eigenvalues must be positive. So there is sum over K, yeah. But, okay. Next.
If sum over K, then
It just it's a trivial sum because বাকিগুলো সব শূন্য, it's nothing. And there is obviously a sum there, I'm sorry. When you write the components, you give a sum, but
Right.
that sum is,
Implicit.
yeah. Sorry, the sum should be there. If you see indices,
Yeah, always.
there will be sum. Okay, that's not necessarily true if you have only one index. But if you have an equation and both sides have one index, not necessarily you need to have a sum. But if you have more than one indices, basically it's hard to put into words. If you have matrix multiplication basically, then you have a sum. That's the way to say. You can have tensors without sum. But
so what is the theorem that you're trying to prove? Can you just remind me?
we're trying to prove that a quadratic form is positive if all the eigenvalues are positive, provided the vector is not 0 vector, and it is negative if all the eigenvalues are negative.
Even
I see.
Yeah, even all if. Yeah. That's why the converse argument went. Yeah.
Got it. Thank you.
So one direction you can easily see that if Q of y is greater than 0, eigenvalues must be positive. Okay. But yeah. So yeah, also you can ensure that if all the eigenvalues are positive, Q of y is positive.
first we proved the converse statement. We took it that if all the eigenvalues are positive.
Now we always take that. That is what is given. If and only if a যেটা given, we start with that one. Necessary part, yeah. This is the necessary part, and the opposite is the sufficient part. That falls into the mathematical logic. There is something called.
I think a course on abstract algebra is what you take, right, to learn how to prove things and things like that.
No, this one is for mathematical first order logic. These are not in abstract algebra as well.
Well, I mean, we don't have a mathematical logic course in one.
Yeah.
Yeah, that's the shame.
But we have something in discrete.
Except in
Discrete.
Do you have it in
your mathematics?
Do you have?
We read it in real analysis.
Oh, there's a subsection.
Yes.
Oh, I see.
In abstract algebra.
Yeah, ওগুলা তো topology বইও আছে you have to.
Topology.
Yeah, well, in Monkrest, yeah, if you have, we have a survey on the set theory. Okay, the set theory, first order logic, Boolean logic.
Yes, that's a was separate and then we have.
Yeah, after this you go to Zernlo-Funkel. You build these logical structures, truth tables, then you go to the axiom of ZFCs and all that. Yeah. We can have a discussion on later on.
Usually in local university courses, especially if they start with this calculus, that's MAT Math 101.
Yeah.
I'm talking about the general.
ব্র্যাকে তো আছে স্যার কিছু ওই ডিসক্রিট ম্যাথ কোর্সে কম্পিউটার সায়েন্সে বাট ম্যাথের আন্ডারে করে না
But usually not for everyone. So like,
it should be for everyone না
this logic foundation.
it's very sad. Okay, so I'm going to leave the proof for the second statement to you because it's the same thing, you just run the other way around. Okay, so okay, good. So we have been able to establish one connection. Okay, what was the connection again? Quadratic form sign is depending on the eigenvalues. Okay, now the main connection is that now we build BYLD the connection of the nature of a stationary point in terms of the algebraic sign of the quadratic form y Hessian at A. Well, A is the stationary point, nature of a stationary point A. So now we build that. So that's when we build that, we put it in a theorem, express it in a theorem. Theorem 2. Let, maybe I can also cast it as a theorem. In physics results, we don't do that. But we could do that, if we want. If we have a result for arbitrary values, then we can cast it into a theorem. So this is true, then this is possible. If we have an algorithm. Usually people don't do that. Let F be a scalar field with continuous second derivative, second order partial derivatives. Okay, so in general this would be a mixed partial derivative in an n ball. Okay, and when I say n ball, it's an open n ball, in an open n ball, and let the Hessian, this denote the Hessian matrix at a special point. Stationary point is a special point. Okay, at A. Then we have A if all the eigenvalues of the Hessian matrix are positive. Okay. So this statement can be cast this way, that lambda k is greater than 0 for any k, which would mean that all of them are positive. Then F has a relative minimum at A. Kind of tells you that relatives are not very important. Because it's relative. It's always comparable.
So can you explain the Hessian matrix?
A Hessian matrix is okay. So okay. So a Hessian is basically this one. When you cast this thing in a matrix form, that's a Hessian. So for example, if 2 by 2, how many second derivatives I have? D11, D12, D21, D22. Now if all of partial derivatives, yes, then second order partial, yeah. And we are demanding that they're continuous, second order continuous. That means these two are equal. Okay? So then the Hessian becomes this. Okay? This is the Hessian matrix. Now this is a symmetric matrix. Why? Because if on the diagonal you reflect, they are the same. That's the definition of symmetric matrix. which means that H transpose is H. That's the definition of a symmetric matrix. And it's real because we are working on real numbers. So in linear algebra, you will see that we call this field. So the matrix is over the field. So which field? Real field. So if the field was not real, then it could have been complex or something else.
But here it is real. For initial matrix, it will be
No, not necessarily. It's just defined for second derivatives. Yeah. Then it will not be symmetric, but it will be then Hermitian. Yeah. Okay.
So notation wise, we should put the comma.
Yeah.
They don't put this.
Yeah. এখানে একটা কমা দেওয়া উচিত তাই না? I should keep a comma. বই দেয় নাই না? Yeah, he missed it. Apostle sometimes.
Second order is
Yeah, yeah. Yeah. ধরে নিছে যে আপনি যখন অনেকগুলো বেশি ইন্ডেক্স থাকবে, আপনি যদি ফোর্থ অর্ডার নেন তাহলে আপনি আর কমা দিতে চাইবেন না, you will not want to do that. Yeah, K, L, M, N, O, P. If you want to have 8th order derivative, comma সংখ্যায় যদি yeah, here comma is actually lower than your 2. যদি 8টা still would be lower, still be 7টা হবে, but it would be very much comparable. You don't want that to happen.
So is there any shorthand for that? Which dimension is
Well, Dij.
it?
This is without the comma.
Or maybe range. I M to D I. No.
Well, there are shorthands like this.
XX. Meaning.
Second derivative. This means that d square have dx square. My partial PD jara kore ora eta use kore. But this can take you into difficulty if you do vector fields. Well, fxx will not, but fx will.
Yeah, applied mathematicians use that notation a lot.
Oh, no.
Right?
Yeah, I think so. But pure math.
Assembly, but
But pure math jara PD kore.
হ্যাঁ PD
PD
people are as much applied mathematicians.
But there are tau to pure math pare. So PD people এর কাছে applied mathematician দের কাছে Navier Stokes solution আছে, pure mathematician দের কাছে নাই। এটা খুবই হাস্যকর একটা ব্যাপার আর কি। Even physicists have solution, mathematicians don't. Okay, so we have Yang-Mills theory. Yang-Mills theory is a partial differential equation, and it describes 4 manifolds. And we have assumed it is true, and we can explain many things. However, we do not know if its solution exists or not. So, yeah. So that's very important reason why pure math is very important. A, so I wrote down the A, no? And the B second statement is if H of A is the Hessian has both positive and negative eigenvalues, then F has a saddle point at A. I think আমি একটা মিস করছি, এটা সি হবে। আমি যেটা মিস করছি আমি সেটা লিখবো না, আমি বলবো হচ্ছে কপি ইট ফর দ্য ম্যাক্সিমাম। আমার লিখতে গেলে আর কাটতে হবে। all you need to do is to say that all the eigenvalues of H are negative, then F has a relative maximum at A. Okay? Can you follow?
Then just write A comma B and
Yeah.
then the maximum goes
Yeah.
over.
আমাদের আগের থিওরামটা তাহলে তো অর্ধেক থেকে যায়, তাই না? A, B captures the first theorem, and C is what tells you that there can be a situation where The Hessian has positive and negative eigenvalues. So you can think of in this way that it doesn't know where to go. Saddle is something like that. If you have maxima, if you have minima, you know where you're going. So you're climbing the hill, you're going to the maxima. You're climbing down, you're going to the minima. But if you are at a point, you have a maxima on one side and minima at the other side, you don't know where you're going. So you're stuck there. That's a saddle. And physicists work on a saddle. Saddle point. Yeah, আমি পোস্ট করব একটা ইউজ অফ স্যাডল পয়েন্ট Yeah, I will post
I thought saddle was a plain flat thing.
Yeah, at the saddle point you have a flat plane. At the saddle point you have a flat plane. At the point. It's an extrema. Okay. However, it is neither maxima nor minima. It's a valley. So you can have a
So that you can sit down.
Yeah, you can sit down, yeah. So you can have maxima, you can have minima, but you can have certain surfaces which are neither maxima nor minima, it's like a saddle. So here it's neither maxima nor minima. Here you have a maxima, in this here you have a minima, but this is neither maxima nor minima. Where you sit on a horse. So one can use the saddle point approximation to find the Stirling's approximation from the gamma function. So I will probably post it. That is not related to multivariable. That is just to know what the saddle point does. কিন্তু এটার জন্য আমাকে শুরু করতে পারে মানুষ যদি ভয় পেয়ে যায়
Someone explained it wrong during one of my courses. What the definition of saddle point?
Oh yeah,
Saddle point.
yeah.
That's why it became confused.
Oh yeah. Why?
They explained it is just a flat plane.
That is true. মানে at that point you have a flat plane. Yeah, that's true. But মানে এটা খুবই মিসলিডিং যদি আমি বলি এটা মানে only flat plane is misleading. মানে okay. You see why? Exactly. মানে if that's what we are purporting today. No, any curved surface, you zoom very close, it is flat. So every plane is flat plane up to approximation. So that kind of gives you an essence of Taylor's theorem. Taylor's theorem is everywhere. If you take it by heart, if you take this by heart, you can understand so much. That rigorous math will take you a lot of things to do. You can do still rigorous math, but by heart you know this is true. Okay, then it becomes much easier for you to do. Okay, let's prove this theorem. So you have this quadratic form, and by Taylor theorem, okay, Taylor's theorem, a formula, okay, formula up to approximation, we have f of a plus y minus f of a is equal to 1/2 q of y plus y mod square e2 a y. Okay, I should be doing it a bit faster. So where e2 goes to 0 as y vector goes to 0 vector. So fairly obvious statements. So what do we want to do? So এখানে আসলে আমরা কি প্রুফ করতে যাচ্ছি? আমরা প্রুফ করতে চাচ্ছি যে f has a relative minimum at a. Okay. What do we mean by relative minimum and relative maximum? It means that at that point f of a either greater than 0 or less than 0. Okay? ঠিক আছে? Okay? That point is either greater than 0 or less than 0. So সমস্যাটা কই? সমস্যাটা হচ্ছে এই এরর টার্মে। যদি একটুক থাকতো তাহলে কিন্তু প্রুফ জানো, কারণ এটা পজিটিভ হবে যদি এটা পজিটিভ হয়, এটা নেগেটিভ হবে যদি এটা নেগেটিভ হয়, এবং এটা পজিটিভ নেগেটিভ হবে যদি আগেন ভ্যালুগুলো পজিটিভ নেগেটিভ হয়। সমস্যা হচ্ছে এই জায়গাতে না, এরর টার্মটাকে। সো এটাকে বাউন্ড করতে হবে। সো এটাই আমরা করতে যাচ্ছি। I thought somebody said something. So এটাই আমরা করতে যাচ্ছি। So we'll prove will prove that there exists some r which is a positive number such that if y is bounded from 0 to r, the norm of y, the algebraic sum the algebraic sign of the difference, okay, is the same as that of q of y. Okay. Proof এর মধ্যে একটা proof statement. Maybe you could have done this as a lemma, but okay. Let lambda k for any k, which means that all the eigenvalues are positive. Okay. Also let some h, which is some minimum of all the lambda k. Okay. So if u is less than h, some u, have I defined what u is? No. So let, I'm just going to define u সম্পর্কে. So let u, so what is u? You see, in programming, if you start writing a conditional statement, before that you have to define it, otherwise program নেবে না ওটা. ম্যাথেও একই রকম, দেখে define করতে হবে. So computer scientists are naturally becoming, well, they naturally have a math background. So what do I do with the u? What is u? uটা হচ্ছে এক ধরনের it's an well, it's not even that. Let u be a real number. Let u be a real number such that u is less than h. Okay. Then so lambda k minus u is greater than 0 for any k. Is that okay? So smallest eigenvalue, ওটা হচ্ছে ছোট, বাকি সব eigenvalue তো smallest চেয়ে বড়, তার ওদের থেকে u বিয়োগ করলে তো obviously পজিটিভ, আবার যেটা smallest ওটা হচ্ছে ছোট জিনিস আমি বিয়োগ করতেছি, so এটাও by default positive. So that's true. Okay. So what is the interpretation of these numbers? So these numbers are eigenvalues of this matrix. Hessian minus you have u times identity matrix, and this is an identity matrix. And essentially this is these are the eigenvalues of this matrix. Okay. Any question? The eigenvalue of a unit matrix is identity. Yeah, Hessian minus u times. Okay, so the eigenvalues of an identity matrix are all 1. So, okay, so it essentially boils down to finding the eigenvalues of H, which are already lambda k.
But why do we just put this minus term?
Because we have lambda k minus u combinations. And if you write this out, what does this matrix would look like? It look like lambda 1 minus u, lambda 2 minus u, lambda n minus u, no? This is the... All right? Very good. Thus, oh, there is another funny thing that identity matrix itself is a real symmetric matrix. So we are not losing anything. Everything holds. Okay. কেন এটা দরকার এটা আমরা দেখব এখন যে কেন আমরা এই this is a construction to prove this. We want to prove this. This thing is a construction to prove this. এটা আমরা prove করব এটা prove করার জন্য এটা একটা construction. It's not the only way to prove it. In mathematics, I don't know if there is a statement like there is the only way to prove it.
So we are proving A, right?
I am proving this red closed to red enclosed to yeah whatever that is. Trying to prove that actually. সকালে ঠান্ডা লেগে গেছে এখানে বাতাসে got that. Okay, that's by theorem 1. Should be running faster than this. Okay. It's greater than 0 for all y not equal to 0. Does it make sense? That's why I said it works for our theorem 1. Our theorem 1 ki bole, if I have a real symmetric matrix, then eigenvalues, if the real symmetric matrix is, if the quadratic form given by the real symmetric matrix is positive, then the eigenvalues are positive. Or if the eigenvalues are positive, then the quadratic form is positive. In this case, we started with the eigenvalues are positive, so we find that quadratic form is positive. Okay? ঠিক আছে? Mouthful of statements. Yes, sure.
I was thinking about the bounding of the value of the u. Then I realized that you don't need another lower bound.
Because it's self-bound. Yeah, but h is a bound.
Upper bound is h.
H, yeah. Lower bound doesn't need to be. It can be anything lower. It doesn't have a lower bound. Very good.
Yeah. You don't need the lower bound.
Yeah, for the moment it doesn't seem to require a lower bound. Let's see. যদি দরকার হয় থিওরেমের কোনো একটা জায়গায় গিয়ে তাহলে করে দেব, না হলে হচ্ছে জেনারেল স্টেটমেন্ট। That's how it should work. You know? You start with the most general situation. মানে ফুল স্পেস নিয়ে কাজ করতেছি, ফুল স্পেসে হচ্ছে না, তারপর স্পেসটাকে ছোট ছোট করতে করতে আলটিমেটলি you find the region where it works. Not unitary matrix. What is the unitary matrix? U.
U as in, sorry, U is
Yeah. ও আচ্ছা, I'm sorry. ও আচ্ছা কীভাবে আসছে এই লাইনটা? ও আচ্ছা এই লাইনটা কীভাবে আসছে? So okay. This combined with this gives you this, right? Then this part of the line is U transpose, no? U is a number, I is identity matrix. So identity matrix can just not be, it's there, but we cannot appreciate it.
so that's the norm.
Yeah. Writing is a machine. Once you start it, you have to. Okay, we may not write. Yeah. So very good. We have this. Then, okay, very good. What else? Okay, very good. This is true. এখন এটা true কেন? When u is less than h. This is true when u is less than h. Now, because u is less than h, take u to be h over 2. Now, this 2 can be anything, any natural number. Very good. Then this will imply, what will this imply? This is nothing but q of u. So আমি এই জায়গাতে এটার জায়গায় q of y লিখতে পারতাম. So okay. So if this is true, that means that q of y is greater than half of h y mod square. No, I'm just substituting the u value here. Okay. Since E2 tends to 0 as y tends to 0 vector, okay, that comes from Taylor's theorem. There's a r greater than 0, whenever I say there exists, say r greater than 0, such that E2 norm, well, in this case, this is a real number, so it's just modulus is h over 4 for okay. Can we do that? So the lower bound of y is 0, upper bound is r. So whenever y is in between 0 and r, we pick r such that this is true. মানে ওইভাবে পিক করতে হবে যাতে হচ্ছে এবং আমরা এটা করতে পারবো কিনা। Can we do that? Okay. What is h? H is the minimum of the eigenvalue. Okay. So we can do that because it depends on y. E2 depends on y. So if I make a line which connects 0 and r, which connects 0 and h, and beyond that or something that, okay, I have a line, and that along that line y approaches 0, E2 approaches 0. So whenever I have a bound on y, I can demand that E2 satisfies this condition. So that if I smoothly go to 0, this also goes to 0. Okay? Okay? Now y doesn't have to do with anything to with h. E will do, মানে e এর bound h এর সাথে হবে, but y এর boundটা r এর সাথে হবে আর কি। আমি একটা r পেতে পারি। Does it make sense? Okay. So you have a line, so y approaches 0. So if y approaches 0, your E2 approaches 0. Okay. Now you're saying that your y is bounded by some r. Okay, there is some r where y is bounded by, such that you can bound this error to be this. You can bound your error. Okay. It is always true. You can always find any bigger thing and you can do that. এবং এটা করা যাচ্ছে এক্ষেত্রে because h is a positive number to begin with. But it doesn't seem to have a very deep fact. You can always do that. There doesn't seem to be any obstacle in doing it. Is there any obstacle in doing it? I don't see. You can always do that. Just formally writing it. It's now a matter of formally writing it. The only thing E2 had to satisfy is that it goes to 0 as y goes to 0. Nothing else. So you can choose a y such that it has a bound like this. Okay? আপনি যদি y কে যেরকম করবেন সেরকম বাউন্ড নেবে আর কি, এররটা ওইরকম হবে। You have a control over the error. So is this statement correct? Yes, correct, right? It is from Taylor's theorem. লেস ইকুয়াল কারণ এই জিনিসটা আসলে বড় 0 হচ্ছে, রাইট? এবং 0 সমান হতে পারে যদি y 0 হয়। রাইট মোস্ট কী হবে? রাইট মোস্ট টাইম ভ্যালুগুলো বসাবো। E2 এর বাউন্ড মানে E2 ইজ লেস দেন, ওকে। আবার আরেকটা ব্যাপার হয়ে গেছে যে এই জিনিসটাকে আমি কি লিখতে পারি? সো দ্যাট ইজ ইকুয়াল, দিস লাইন অ্যাকচুয়ালি, ওকে, দিস লাইন ইজ অ্যাকচুয়ালি ইকুয়াল টু 1/2 h over 2 y mod square. So 1/2, this is q of y. So this thing is actually less than this thing. মানে এমনভাবে চুজ করতেছি, স্ট্র্যাটেজিটা হচ্ছে এরকম যে আমি এই জিনিসটাকে এমনভাবে চুজ করতেছি যাতে এটা ছোট হয়, হাফের ছোট হইতে হবে। কেন? হাফটা টেলরস থিওরেম আছে তাই। Yeah. Okay. Any questions? Can you see where this is heading to? Karan, now I'm just going to write down the Taylor's theorem. However, with a little bit of a change, টেলরস থিওরেম থেকে এটা আসে। কেন আসে? টেলর থিওরেম বলে হচ্ছে এটা প্লাসের সাথে ইকুয়াল। ওকে, তো যদি আমি এটা থেকে এটা বিয়োগ করি এবং এটা যদি এটার চেয়ে বড় হয়, যেটা আমরা দেখাইতে পারছি যে এই জিনিসটা আসলে এটার চেয়ে বড়, গিভেন আমি ওয়াইটাকে বাউন্ড করছি আর কি। এটাই হচ্ছে আসলে কাজটা ছিল। এটা তো অবশ্যই পসিবল, তাই না? আমি যদি বাউন্ড করি আমি দেখাইতে পারবো এই জিনিসটা এর চেয়ে বড়। That's the error term is exactly there that you can bound it, okay, to make reasonable statements, and it's an error term. It's not supposed to be bigger than your original result, okay, which has a proof in Taylor's theorem why that statement is true. So now it makes sense. Which itself is greater than 0. Because half of q of y is greater than nothing. Okay. Therefore, f এর কি আছে এখানে, ম্যাক্সিমা না মিনিমা আছে? All the y's with respect to a have a higher value than a. That means it's a minimum. Yeah, therefore, f has a relative minima. So in single variable calculus, you have an extremum value theorem. No? That doesn't tell you how to find the extremum values. That tells you there are extremum values, right? If you have a continuous function, okay, between the boundaries, then you can show there are extremum values. But yeah. F has a relative minima at A. Okay, so I would request you to run the same argument for B to prove B. Run the same argument, but you have to change the signs in that case. Now, saddle pointed প্রুফটা একটু ট্রিকি। For part C, আমাদের একটু তাড়াতাড়ি করতে হবে। আমি কি ওকে না বলে আমি এগোবো? Let us not look at the watch for some time. না, not mobile, watch. You can still use mobile without looking at your watch, clock. Let lambda and lambda 2 be two eigenvalues of opposite signs. It's a little subtlety, but not really big. Signs of age. Okay. So আমি এটা একটু ক্যাচ আপ করা যায়। ওকে, তাহলে আমরা যেটা করবো লেট করবো আমরা এইচ। এখন দেখা যাবে যে এই এইচটা আমরা সবসময় পজিটিভ রাখতে চাই। দ্যাটস ওয়াই উই উইল হ্যাভ দিস থিং, যে এদের ম্যাগনিটিউড নিয়ে কথা বলবো, কোনটা মিনিমাম ওটাকে আমরা এইচ হিসেবে চুজ করব। এবং ইউটা যেটা বলতেছিলা যে ইউটা রিয়েল নাম্বার, বাট ইউ ডাজ নট হ্যাভ টু বি পজিটিভ। দেন ফর ইচ রিয়েল ইউ স্যাটিসফাইং মাইনাস এইচ থেকে ইউ বড়, এইচ থেকে ছোট, কারণ এইচ হচ্ছে মিনিমাম অফ দ্য টু, অ্যান্ড উই চুজ ইউ সাচ দ্যাট ইট ইজ ইন বিটুইন দিস টু ভ্যালিউজ। ল্যামডা 1 মাইনাস ইউ থেকে এবং ল্যামডা 2 মাইনাস ইউ, জাস্ট দুইটা ভ্যালু আছে, হ্যাভ অপোজিট সাইন্স। ইজ ইট ক্লিয়ার? দ্যাট ওয়াই ইজ ইট ট্রু? এখানে বাউন্ড করতেই হবে। আমি যদি বলতাম যে ইউটা লেস দেন এইচ, তাহলে একটা প্রবলেম আছে, আবার মাইনাস এইচ হচ্ছে বড় রাখতে হবে। হ্যাঁ, তার একটা প্রবলেম হতে পারে, বিকজ আমি ইউটা বিয়োগ করতেছি, ইউর আগে একটা সাইন আছে। সো আই হ্যাভ টু হ্যাভ দ্যাম। সো হোয়াট ইজ দিস? সো ইউটা এইচ এর চেয়ে ছোটো, এইচ হচ্ছে মিনিমাম। ধরেন ল্যামডা 2টা মিনিমাম এবং ল্যামডা 2টা নেগেটিভ। ওকে, তাহলে ল্যামডা 1 ইজ পজিটিভ এবং ল্যামডা 1 থেকে ইউ বিয়োগ করলে ল্যামডা 1 মাইনাস ইউটা পজিটিভই হবে। ল্যামডা 2টা নেগেটিভ এবং ইউটা ল্যামডা 2 হচ্ছে ছোট, তাহলে ল্যামডা 2 স্টিল নেগেটিভ থাকবে। কারণ ম্যাগনিটিউডে ছোট, তাই -2 হলে এটা 1 হবে, ম্যাগনিটিউডে ছোট না, ওই সেন্সে না যে -2 -3, ওই সেন্সে না, ম্যাগনিটিউডে ছোট। So, okay, very good. So you can think more about it and consider all other possible cases, then you see this is true. So what this implies, আমি এই ধরনের লাইন ইউজ মানে আমি এভাবে ইমপ্লাই দিচ্ছি, বাট ইউ ক্যান রাইট প্রপার স্টেটমেন্টস, আমি এভাবে করছি যাতে আমার সময়টা বাঁচে। আর সো দিজ আর আইগেন ভ্যালুস অফ HA minus UI. ওকে, কেন আমি ধরে নিচ্ছি যে আমার দুটো আইগেন ভ্যালু আছে তাই, which would imply যে এটা has, মানে you would write the words imply, if you write this in a exam paper, ঢাকা ভার্সিটি তো 0 দিয়ে দিবে। আমাকে দিছে মাস্টার্সে তানভীর হানিফ স্যার SO2 U1 আইসোমরফিজম জানে না, সে আমাকে মানে আমি ওইটা ইউজ করে একটা প্রবলেম করছি আর কি, রোটেশনের। হ্যাঁ, ও আচ্ছা, আমি বলতে পারবো স্যার, আমি তো কেউ না, ফার্স্ট আর সেকেন্ড হচ্ছে somebody recognize, it's a true event, it's a true event. হ্যাঁ,
कोई सारे नाम में अवेलेबल है सर, पब्लिक वीडियो
SO2 U1 আইসোমরফিজম সে অ্যাকসেপ্ট করবে না আর কি, SO2 U1 আইসোমরফিজম। সে আমাকে 0 দিচ্ছে। আরও খারাপ কি, মানে ধরেন উনি ধরেন ম্যাথে তো না, ল্যাগ্রাঞ্জিয়ান থেকে মানে অ্যাকশন থেকে তো ল্যাগ্রাঞ্জিয়ান আসে তাই না, তো অয়েল ল্যাগ্রাঞ্জ ইকুয়েশন তো এখান থেকে আসে। আমার ফ্রেন্ড ইকুয়েশন অফ মোশন ডিরাইভ করছে হচ্ছে ভেরিয়েশন দিয়ে দিয়ে, ওকে 0 দিচ্ছে। রিজন কি, তুমি অয়েল ল্যাগ্রাঞ্জ ইউজ করো নি। And it has grave consequences, আমাদের গ্রেডস খুবই খারাপ আসছে, খুবই খারাপ। আমার ফ্রেন্ড ফেল করছে, my friend failed this course.
We had a worse. We had a T.
Do you guys have pure math courses?
না মানে ওইটা থিওরিটিক্যাল ফিজিক্স, মানে না অবভিয়াসলি না, পিওর ম্যাথ থেকে 100 হাত মানে 100 বললে কম হবে, ইনফিনিট হাত ধরে।
Now they're minor physics. Really, very good.
We had an optics teacher who gave us proofs in exams. So I don't know. He had a rule that if you have to cut for correction, like say you're proving something and you realize that you made a mistake, then you cut it and then do the right stuff. If you cut once, you get 0. I mean, it's so horrible. Like,
It has consequences for our career.
I got my first 0 in my life in his course.
you got a taste of 0.
Test of 0.
I got my first taste of 0. I think 60 out of 43 people got 0 because of that reason.
That's terrible.
It's very terrible.
Eigenvalues, yeah. So this makes sense, no? জাস্ট এই স্টেটমেন্টটা কীভাবে লেখা, এভাবে লেখার উদ্দেশ্য হচ্ছে যে নেয়ার এত মানে হচ্ছে নাও ইউ ক্যান বাউন্ড দ্য ম্যাগনিটিউড অ্যাগেন such that your E2 is less than h/4. ওকে, এটা সত্য হবে যদি আমি ওয়াইটাকে বাউন্ড করি এই লাইনে, along this line. And what does it imply? Well, তাহলে তো হয়ে গেল, তাহলে দেখতে পাচ্ছি যে এটা একটা স্যাডেল। ওকে, তাহলে thus the sign of মানে এটার যে সাইন আমার FA প্লাস ওয়াই এর সাইনও মাইনাস এটার সাইনও একই হবে, কারণ আমাদের এটা সত্য হওয়ার মানে হচ্ছে আমাদের ওই আর্গুমেন্ট যেটা আমরা আগে রান করেছি একই আর্গুমেন্ট আমরা এখানে রান করব, মানে আমরা এই লাইনটা লিখতে পারবো। So therefore the sign of atho is the same as Q of y, which is essentially this thing, which means it's a saddle. কারণ এর পজিটিভও না নেগেটিভ, মানে it could be positive, it could be negative. So we are done with this theorem. Now we will look at an example. And an example is error example. Actually, it's the least squares. It's an example. Least squares method. So I said I replied to the question first class. You asked when you saw the error, you asked the second class problem that the error is something, has it something to do with least squares? The answer was yes and no. The error in that case is not related to least squares. Why? Because it was linear, so nothing to do with squares. However, it was related to Euclidean metric. So you increase one more variable, or you increase your dimension of the space, then you have a least square situation. Okay? So E2 is related to the least square problem. Having said that, that kind of problem is in apostole, but I will do one problem which is intuitively made up. So let's do this thing, something like this. Suppose I have some pair of points. I have some points. I could have more points here. When I have coordinate dilam, suppose I have another point 1,5 or something. So I have some bunch of points. And the question is, draw a quadratic curve given these points. Okay? Is this possible?
Yeah.
Okay. Let's see if it's possible. So let us
More than 3 points.
let's try to see if it's possible or not. So আমাকে যেটা quadratic line আঁকতে বলছে, তো আমি quadratic line general equationটাই লিখি যে at square plus bt equal to d, suppose. Okay.
Did you say quadratic line?
মানে sorry, quadratic function. It's a curve. A line is just a twisted word for a curve. Yeah.
Function.
Well, I mean, line is so.
A word line. It is a word line.
Yeah, you're right.
I can.
Line can be a straight line for somebody. For someone it can be a curve.
Yeah.
For mathematicians, it's a complex plane.
That's true. See one. See. Yeah. Yeah. I'm sorry. At square bt equal to d. D. It could be anything else, but I chose d. Could be. I don't know. আমি সি চুজ করতে পারতাম, বাট আমি সি, আচ্ছা ডি ইউজ করাটা আসলে মিসগাইডেড হবে। এস ইউজ করা উচিত, কারণ এটা একটা ভেরিয়েবল, মানে ইট উইল বি সামথিং, মানে ওকে। সো ইটস লাইক ওয়াই, ইটস লাইক ইফ ইউ কল টি ইজ এক্স, টি বলার কি দরকার, আপনি বলতে পারেন এক্সই বলো। কি সমস্যা? হ্যাঁ, ঠিক আছে। So what is my A? So let me construct some matrix theory here. 1, 3, 2, 1. So the problem is that we have some bunch of points and you're asked to find a curve which fits this point. But the question is, does it...
Would there be another plus c there equal to y?
Plus c, not necessary. Let's see. Do we need a constant term or not? Let's see.
The curve will have to go through the origin.
Yeah, goes through the origin. Yeah,
Yes.
yeah. We can add a c, or we can also say, okay, I'm not changing it. Say, however, okay, yeah. Let's put it that way. আমি একটা পয়েন্ট তাহলে কমাই ফেলি, শুধু আমার অনেক বেশি লিখতে হবে। 1, 3, 2, 0. That's it. Okay. আমি এখানে রাখবো হচ্ছে এর বর্গ। সো এটা হচ্ছে সেকেন্ড কলাম ইজ দ্য স্কোয়ার অফ দ্য ফার্স্ট কলাম। লেট এক্স হচ্ছে, এখন পুরো বিপদে আমি, হ্যাঁ, পি, ও জিসাস, হোয়াট ইজ দিস, P, Q, R, S. Okay. Yeah. So, and Y is my Y coordinates. 2 minus 1 4 0. So now this equation is this equation. Can be cast into a matrix equation. Okay? বর্গগুলো হচ্ছে হিট করবে ওকে ওয়েল অ্যাকচুয়ালি আমার একটা জিনিস চিন্তা করতে হবে আমার তো PQRS কেন আসছে এখানে সরি PQRS তো হবে না এটা হবে AB ওয়াইগুলো হবে এটা সরি yeah now it makes sense এই বর্গগুলো হিট করবে হচ্ছে A কে হিট করবে so this will hit the quadratics basically so 1 1 and then you see this is true so that means the y is nothing but so A is a matrix whose matrix representation is something like this so AIK say XK where the sum goes for the number of variables you have in this case 2 okay. How many equations do you have? 1 2 3 4 equations. How many unknowns do you have? 2. It is an over determined system. Okay.
Why the YK from?
YK? I'm sorry?
You define Y.
I define, these are the Y's. Y গুলো হচ্ছে Y coordinate গুলো তুমি যদি এগুলা দিয়ে মাল্টিপ্লাই করো দেখবা হচ্ছে এই পয়েন্টগুলোর জন্য ইকুয়েশনটা সত্য হবে ওকে তার মানে ইট ইজ আ ওভার ডিটারমাইন্ড সিস্টেম দেয়ার ইজ নো সলিউশন সো উই সে if you have n unknown and m equations such that you have m is greater than n, then this is the system. Okay. That's all right. So মানুষজন তখন এই প্রবলেমকে ট্যাকল করা বাদ দিয়ে দিচ্ছে কারণ এটা সুন্দর ট্যাকলিং হচ্ছে না there is no solution what to do then there came out somebody named Gauss then Gauss came up and he said okay ঠিক আছে প্রবলেমটাকে রিস্টেট করি let us restate the problem so let me cast it as a general problem not just 2 variable but n variable so cast করব হচ্ছে yi k equal to 1 to n my unknown variables and I k x k okay so Gauss came up and he said okay this is true then let's consider some error this is the error but this is a quadratic error or a square error he called it probably quadratic means square but it's least square so you should call it a square somehow y minus k equal to so this is sine I y minus k equal to 1 to a I k x k and square it so that's the idea of a square error 1 to m okay and Gauss said okay let's minimize this thing minimize it okay you can't have the line curve going through all these points however you can make it arbitrarily close not arbitrarily close but better approximating the points okay so that's how Gauss contributed to regression analysis or statistics these squares yeah fit a curve fitting yeah this is exactly graph fitting problem so if you try to minimize this thing so this is a problem with the error but we are going to linear algebra to demonstrate it okay so for L you do this and you have I equal to 1 to m yi minus sum k equal to 1 to n a I k x k minus a I L equal to 0 এটাকে minimize করার মানে হচ্ছে you have to set this to 0 okay so that kind of rings with our next situation which I'm going to talk about Lagrange multiplier so what is this এই জিনিসটা আসলে কি so you have look at the first term yi a I L So এটা আসলে matrix multiplication not with A but with A transpose. Does it make sense? This is A transpose Y. কারণ আমি যদি এটাকে transpose করি, it becomes a matrix multiplication. Okay? If I transpose this thing, it becomes Li with a transpose with Yi. Then it's matrix multiplication. Okay? Similarly, you can write this term and the whole equation becomes this. A transpose Y is equal to A transpose X. Or I made a mistake, it should be A transpose AX. From here, you want to find X, which is nothing but AT A. So you have a solution. So Gauss বলতেছে দেখো solution করা যাবে না, এই যে দেখা যায় this is solution. So that's the method to do this thing. Okay, you calculate these things and it is calculable. You have a least square approximation for a curve that best describes those points. Okay, and that's an error, a square error. Okay, good. Next, moving on. Okay, Lagrange multiplier. Lagrange multiplier, I will introduce it intuitively today. Intuitively. Okay, so what is the idea? It's trying to find an optimization. So let's cast this thing as a problem, as an optimization problem. So I cast it as an optimization problem. Okay, so what is it? Okay, suppose you have some company. Let you have a company. Let you have a company. Company মানে তো যেটা business company, not bunch of people doing nothing. Sorry. Labor, which is $10 per hour. Suppose you have to put some labor in it, so you put $20 per hour. And you have you need, so a company to the steel company. Suppose কিছু steel দরকার. Suppose $2,000 per ton. Okay, and your revenue. I hope revenue মানে আমার কোম্পানিতে কি পরিমাণ টাকা আসবে, সাপোজ ইটস সাম ফাংশন, সাপোজ আওয়ারের ফাংশন এবং স্টিলের ফাংশন, ইট কুড বি এনিথিং, আমি জাস্ট প্লাগড ইন সামথিং। বাজেট, আমাদের বাজেট দরকার, কারণ আমি তো ইনভেস্ট করতে পারি না, আমার বাপ তো হচ্ছে বিল গেটস না, রাইট? বর্তমানে সবচেয়ে ধনী কে? বিল গেটস না, জেফ বেজোস, আমরা তো জেফ বেজোস না, রাইট? সো সাপোজ এটা হচ্ছে আমার কনস্ট্রেন্ট, কি করছি আমি? $20 per hour. ওকে, সাপোজ আমার কত টন দরকার? ধরো আমার টন হচ্ছে $2,000 পার টন, তাহলে আই ডোন্ট নো কত 10 গুণ করলেই তো আমার 20,000 হয়ে যায়। যদি 20,000 আমার থাকে, তাহলে আমি কত দিব এখানে? কত স্টিল দিব? কত টন স্টিল দিব? 10 টন স্টিল, 8 টন দিতে হবে, রাইট? সরি, তাহলে আমি একটু করতে পারি, বাজেট বাড়াই দিই আর কি, না আরো বাড়াই দিই। এখন মনে হয় ঠিক আছে, না হলে আমি আরো কয়েকটা শূন্য বাড়াই দেবো, সমস্যা নেই, ঠিক আছে। থ্রি ইডিয়টসের কথা মনে পড়ছে, ওখানে চতুর্কে দেখায় যে একটা শূন্য বাদ দিলে, 2টা শূন্য বাদ দিলে কোনো সমস্যা নাই, আরেকটা শূন্য বাদ দিলে সমস্যা। Okay, so this is a constraint. Okay, very good. So this is a problem one has to solve. It's an optimization problem. Egula given, constraint to given, revenue given, সব কিছু given. কথা হচ্ছে আমার কি করতে হবে, আমার এই জিনিসটাকে, রেভিনিউটাকে আমার কি করতে হবে, ম্যাক্সিমাইজ করতে হবে। এই ক্ষেত্রে রেভিনিউ আমি চাই যে এই বাজেটের মধ্যে আমি আমার রেভিনিউকে ম্যাক্সিমাইজ করব। ওকে, সো R is usually going to be a curve. Okay, so this is a curve. Curve এরকম হইতে পারে, এরকম হইতে পারে। আমার কোম্পানি যদি খুব খারাপ চালাই তাহলে এরকম হইতে পারে, রেভিনিউ নেগেটিভ হইতে পারে। হ্যাঁ, ওকে। বাজেট হচ্ছে একটা লিনিয়ার ইকুয়েশন, রাইট, আ লাইন। হ্যাঁ, সো সাম সর্ট অফ আ লাইন। এখন লাইনটা অনেক রকম হইতে পারে, রাইট, বাট আমি চাই ওই লাইনটা, যে লাইনটা হচ্ছে আমার কার্ভকে ইন্টারসেক্ট করবে একটা পয়েন্টে। ওকে, সো আই এম লুকিং ফর ইন্টারসেক্ট করবে বলতে মানে ট্যানজেন্ট হবে, টাচ করা মানে ওই পয়েন্ট দিয়ে যাবে, মানে ওই পয়েন্ট ইন্টারসেক্ট করবে, নো আদার পয়েন্টস। Tangent হবে basically. I want this point, yeah. Okay, because that's going to be a stationary point. Intersect বলি না, but intersects at one point. Intersect যেটা আছে সে more than one point intersector. Touches the curve, it's probably, yeah. Intersects the curve বলি না. Yeah. Second. Yeah. Yeah, intersection. Right. So এই পয়েন্টে একটা যদি আমি গ্রেডিয়েন্ট নিই, সো এটা আমার আর এবং এটা আমার সরি কোনটা আমার আর, আরটা হবে আমার ইয়াতে। সো ওয়ান উড বি ব্লু কালার, সো দিস ইজ মাই বি অ্যান্ড দিস ইজ মাই আর। ওকে, সো হোয়াট হ্যাপেন্স দ্যাট দিস ইজ এ গ্রেডিয়েন্ট টু মাই, আমি উল্টাটা করছি না, this is my line, and this is my constraint, so this is my budget, and this is my revenue. So আমার revenue এই যে কার্ভটার এই পয়েন্টে আমি একটা গ্রেডিয়েন্ট, আমি তো যে কোনো পয়েন্টে গ্রেডিয়েন্ট নিতে পারি, কিন্তু মজার ব্যাপার হচ্ছে এই পয়েন্টে গ্রেডিয়েন্ট নিলে এখানে একটা প্লেন আছে, ট্যানজেন্ট প্লেন, যে কোনো পয়েন্টে নিতে পারি কিন্তু ওই পয়েন্টে একটা প্লেন আছে অবশ্যই। এবং এই যে পয়েন্টটা, এই লাইনটার সাথেও কিন্তু কি একটা প্লেন, মানে এই লাইনটার সাথেও কিন্তু ট্যানজেন্ট, এটা একটা পারপেন্ডিকুলার অর্থোগোনাল না। সো দে আর অ্যাকচুয়ালি প্যারালাল। Okay, so the optimization problem actually looks like that my delta R, okay, is actually proportional to delta B because directionally they are same. However, magnitude can be different. So that's the idea. Why do you want it to be tangent? Why are we not worrying that we can have this? Why are we not looking for that kind of thing? Maximization the budget. Exactly. মানে কনস্ট্যান্টকে স্যাটিসফাই করে ম্যাক্সিমাইজেশন করবো আমার রেভিনিউকে, বাজেট রেভিনিউকে কনস্ট্যান্টকেও স্যাটিসফাই করবো আর আমার রেভিনিউটাকেও ম্যাক্সিমাইজ করবো। জাস্ট টাচ করছি রাইট, নাহলে আমার ম্যাক্সিমাম তো আমার রেভিনিউ উঠবে না আর কি। সো এটার কারণেই হচ্ছে তারা ইন্টারসেক্ট করছে একটা পয়েন্টে, এবং এটা হচ্ছে আমাদের, তাই এটাই হচ্ছে আমাদের আসলে কনক্লুশন এখান থেকে, তাই না, যে they are actually proportional. Okay, so what is the idea of this maximization problem? The idea is to define a Lagrangian L which is f minus lambda, or in this case it's not f but r, so r minus lambda b. So the gradient of L is the gradient of r, gradient is a linear operator. Okay, so this is 0. Okay, so you have some equations coming up from here and here, and you have a condition which is the budget itself is a number, so it's some budgeter equation ta kothay eta budget ta kintu ekta number b, some number b. So budgeter jonno ekta constraint ache je budget itself is a b minus b is equal to 0, it's a constraint, it's some kind of number. Given these two equations, now you can find the coordinates of your stationary point. Okay, And that's the idea of Lagrange multipliers, okay, where lambda is the Lagrange multiplier. Okay, so আমি জাস্ট একটা থিওরামের স্টেটমেন্টটা বলে শেষ করব। এটা হচ্ছে যেটা মেথড অফ ল্যাগ্রাঞ্জ মাল্টিপ্লায়ার্স। আর একটা ছোট্ট উদাহরণ দেব বাস। So it says if a scalar field f of coordinates this has a relative maximum okay when it is subjected to m constraints or equations. The equations are constraints, so এগুলো হচ্ছে ওই কনস্ট্রেন্ট গুলো। এরকম mটা আছে, সো আমাদের প্রবলেমটাকে আমরা জেনারেলাইজ করছি। আমাদের কাছে একটা কনস্ট্রেন্ট ছিল আগের প্রবলেমে, বাজেট, এখানে অনেকগুলো আছে, ওয়ার অবভিয়াসলি আমাদের m is less than n যদি হয়, then there exists m scalars which are called Lagrange multipliers, lambda 1 to lambda m, such that you can show that the gradient of f is nothing but the sum of these. So essentially this is a vector. You can express them in terms of the gradient of g, which will form a basis for this vector in some sense. You can express delta f in terms of them. Okay. So it's a bit non-trivial to go from one constraint to multiple constraints, but it's not very hard to show this is true. Okay. So if you go through Apostol 316 page, it has a nice picture. So I would request you to read that part. And if you don't understand, we can talk about it, because it requires some geometrical drawing. Okay? So if you look at that, then you will understand that this is possible. Okay. And do I have a time for another little example? Little example. Very little example. Let the constraint be. I have 5 minutes, right, sir? Okay. So I have a constraint, say this. Something, it could be unit sphere, it could be anything, with a norm 1. Because constant ultimately means it's equal to 0. So this is equal to 0. So Lagrange is this. So what is my function? So my ফাংশনটাকে আমি একটু লিখি। সো ফাংশনটা হচ্ছে আমার যেটাকে আমার এক্সট্রিমাইজ করতে হবে, এটা হচ্ছে এটা। ওকে, সো এক্সট্রিমাইজ দিস থিং। সো মাই Lagrange is nothing but it's a quadratic form. So the idea is that we'll see right now, that if you have a quadratic form and if you try to extremize it, you will end up getting an eigenvalue problem. So calculate delta L. From here you can see this is going to be this minus 2 lambda x equal to 0, which is essentially an eigenvalue problem where the constant means this. So your eigenvectors are extremas. Extrema. So one example to connect to the eigenvalue equation. Does it make sense? Doesn't. Okay. So it all goes to there, and you will find. So our curve needs to satisfy the constraint. Okay, and at that point, if there is a stationary point, then the gradient of that should be 0. That's the trick. মিনিমাম বাজেট মানে বাজেটের মধ্যে থেকে আমাদের রেভিনিউ যাতে ম্যাক্সিমাম রেভিনিউ করা। সো বাজেটকে আমরা চাইলে ইনইকুয়ালিটি দিতে পারতাম, আমরা ইকুয়াল দিচ্ছি কারণ হচ্ছে বাজেটটা পুরোটা আমরা ইউজ করব, ইউজ করে হচ্ছে আমরা এমনভাবে কোম্পানি চালাবো যাতে হচ্ছে আমাদের লাভটা বেশি হয়। That's the okay. Okay. So let's go through the geometry. Yeah. Any questions? You can set more problems regarding this.
No.
Okay. So that's it. Thank you for your attention. Can I scroll up?
What is that?
Yeah, sure.
I'll let you. What is that? Oh, that is PhD of that.
Transpose y. Yeah. মানে অ্যাপোস্টোলের নোটেশন স্মল টি, আমি আমার লাইফে মানে কখনো স্মল টি ইউজ করি নাই ট্রান্সপোজ লিখতে। Wiser than me, older than me.
Sir, can you explain the intersection point?
Oh yeah, এখানে. Yeah. It's the curve is obeying the constraint. Okay, so the curve must intersect your curve, your function.
The constraint function.
The constraint function, yeah. Okay.
So, at that point, the revenue will be maximum.
Yeah, that will intersect your curve, but that point has to be an extremum point
Extremum of what?
of your function. Okay.
This is not intersecting.
They are not intersecting. In this case, it's a touching.
They are they're not intersecting.
They are not intersecting. Sorry, I'm using this word intersecting. Yeah. Intersecting at a point is touching.
No, I mean intersection means it can go to one point.
That is also true, no? That is also true. Yeah, Satira both say that's true. Right, intersecting. Okay.
The ছবি যেটা আসছো that there is it's tangent.
It's a tangent, yeah.
They're the
Yeah.
same tangent.
Yeah, this is actually yeah.
That's also that's on the curvature.
Yeah, right. Right. So this is not, yeah, so tangent, yeah, it has to be tangent. In this case, it's a tangent.
In physics, Lagrange equation is used for a very specific kind of Lagrangian, which is, it has the variable and the first derivative of the variable with respect to time over.
Right.
But in mathematics, in maximization or optimization problem, that doesn't have to be the case. A Lagrangian can be
Anything, yeah.
anything.
Any function.
Rotated. And the Lagrange multiplier imposes that the condition that you have to
Yeah.
satisfy.